In part 2 of our ideal gas law series, we'll be answering 3 more questions. The first question reads, calculate the number of moles of gas in a 3.24 liter basketball inflated to a total pressure of 24.3 psi at 25 degrees Celsius. What I would like to do is write down everything that's been given. We've been given the volume. The basketball is 3.24 liters, so I'll denote that as V is equal to 3.24 liters. We've been given the pressure, and normally we want the pressure in atmosphere, so we'll need to switch this later. I'll call pressure P at 24.3 psi, and I'll indicate that this needs to become ATM. And we've also been given the temperature, which is at 25 degrees Celsius. This needs to be converted into Kelvin. Furthermore, we do know the gas constant, which is represented by the letter R in our formula for PV is equal to nRT. Now what they're asking for is the number of moles. So they're asking for the letter N. N represents the number of moles. What I will do is manipulate this formula, PV is equal to nRT, where I'll divide both sides by R and T, giving me PV over RT is equal to the number of moles. Before I start substituting these values into their respective letters, what I would like to do is convert what needs to be converted. So I'll convert 24.3 psi into ATM, and for that I'll use the conversion ratio table. We're told that 1 ATM is equal to 14.7 psi. So let me write that down. 1 ATM is equal to 14.7 psi. So to go from 24.3 psi to ATM, I need to multiply this number by 1 ATM over 14.7 psi. And by doing it this way, the psi units will cancel out, leaving us only with ATM. Our final answer should have 3 significant figures. So we have 24.3 times 1 divided by the number underneath, 14.7, and this gives us 1.65306. And as I mentioned, this needs to be 3 significant figures, but I don't want to round just yet because it will throw off my final answer. What I'll do instead is I'll put a dot underneath the last significant figure that needs to be kept. So now we have our pressure in ATM, that's good, and I can start to substitute that in, but before I do that I also want to convert the temperature. And to go from Celsius to Kelvin, we use this simple conversion, where you take your Celsius and add 273.15 to it. So we have 25 plus 273.15, and since 273.15 is an exact number, we don't take into account the significant figures that it holds. Our final answer should be 298.15. T is equal to 298.15. And remember, Celsius didn't have any numbers after its decimal place, so technically the 15 here shouldn't be included if this was our final answer. Our last significant figure is this 8. So we have this as our pressure. We have 1.65306, that's P, and our volume was given as 3.24. Notice that I'm embedding each of my numbers in brackets. Feel free to do that. If you don't want to do that, that's fine. And our gas constant is written right here, and that's being multiplied to the temperature, which we found to be 298.15. Now by multiplying the numerator and then dividing it by the denominator, we'll end up with our final amount of moles. So let's go ahead and do that. We have 1.65306 times 3.24. This represents the numerator. You don't need to write it down because your calculator can store it. And we'll divide that by the product of these two factors. This gives us a mole value of 0.2189. N is equal to 0.2189 moles. Now we started with 3 significant figures, and so we should end with 3 significant figures. In that case, you see this 8, it will become a 9, because the number following it, the first number to be discarded, is greater than 5. So the number of moles is equal to 0.219 moles, and I'll highlight this for clarity. That's the answer to question number 1. If you'd like to see the answer to question number 2 and 3, make sure to watch part 2 of this series. We'll see you soon.